We are rolling because I want to go over this on camera also for anybody who wants extra help. This is what we learned yesterday. We are just doing a do now to make sure you guys still remember it, because I know sometimes you guys go home and you go like this to see if you can get all the math that you learned out of your head. Okay. I'm going to take attendance and you will be silently working on this. If you are want to check with a buddy near you and see if you guys are getting the same thing, that's fine. Emily, focus. Okay. So remember, when we talked about or yesterday, that meant we have two inequalities. We call them what?
In between.
Compound inequalities. Compound inequalities. So we have two inequalities that will share a graph. Okay?
I see now.
Shh. Melanie, just say here so it's like I'm Melanie, Jacob's here, Carmen's here, Angus? Here. Jack's here, Grayson's here, Ethan?
I'm here.
Okay. Jocelyn's here, Emily, Lex, Natalie, Uriah's here, Faith, Charlotte,
Here.
Alea,
Here.
Lily, and Brianna. Okay, everyone's here. Wonderful. I want to say two quick things, but I do not need your comments. I just need your attention real quick, and then I'll let you continue on your problem. Number one, I have some exciting news. We're going to have a TA, which is a teacher's assistant. Is that gone?
No.
Okay. Just checking. We have a TA coming in, a student from Dayspring, who is very good at math and wants to help in the classroom. So I'm still going to be teaching you the whole time. She's going to be helping. It's kind of like when we're in the middle of this and you guys are confused, and you can just be like calling her over and she can help you and look at your notebook, and she's going to be able to move around the classroom and do that, okay? Her name is, I think it's Masira, does anybody know who that is? 11th to 12th grade. Anyway, she will be here on Mondays and Wednesdays, so we'll have that kind of help. We will treat her with respect and all that good stuff, okay? It's a good thing. The other thing is, real quick, draw your attention to the homework board. We are finishing lesson 1.5 today. Then tomorrow, and so 1.5 homework is due tomorrow. It's only like 9 questions. Once we get through the rest of this lesson, you'll be totally able to do it. And if you get stuck, rewatch the videos on YouTube. For tomorrow, we are learning lesson 1.6. It's just a kind of like a mini lesson, so it's going to take one day. And the only homework for that, there's no lesson 1.6 homework. Only homework for that is the practice test, which is due on Thursday. Is it graded? Yes. Is it graded based on your answers being correct?
It's based on your work.
Based on all work shown. Yes, it's that. There are still some problems that you will not be able to handle right now because we haven't learned lesson 1.6 yet. But we will get there, okay? So just answer the ones if you want to start working on it. Now, answer, not right now, but tonight, answer the ones that you can answer, and then you can fill in the rest tomorrow night. And we will have a full review on Thursday before the test on Friday. Yes? Okay. Yes.
So
I'll go over it.
So question about the test. Is it going to be on everything this week?
So what the good news is, this practice test, if I showed you the real test, you wouldn't be able to tell the difference from where you are. Because the only difference is the numbers. Like number 6, asking you to write an equation looking like this, it's gonna look just like that. It might, instead of saying Steven, it might say Johnny. Instead of saying 6 movie downloads, it might say 5 song downloads or something like that. But the questions, the content are exactly the same. All right? So, raise your hand if you're actually having success with this. Oh, okay, good. A little bit? Okay. Should we go over it together?
Yes.
Okay. Can I have silence? Okay, good. So I'm gonna write each one separately, obviously, because they're two separate inequalities. Minus 3x plus 2 is greater than negative 7. I'll write this one over here just to keep them nice and separate so I don't get confused. Whoops, that's not the right sign. Greater than or equal to 6. And it says it's a compound inequality, which means they might not look like they go together, but they're just gonna kind of share a graph in the end. Even if they don't meet, even if they have nothing in common, they might still be able to, you know, hang out together on the same number line, right? So let's solve each of them separately. If I solve each separately, it's just like what you guys did a few lessons ago. This should be something that you can do easily. If it still feels challenging to you, that's okay. I'm just saying we should be getting comfortable with this now, okay? Because this isn't the hard stuff in this lesson. This is the review, okay? Somebody real quick, shout it out and walk me through this. What do I do?
Minus 2.
On both sides, okay?
-9.
Good, shout it out. What's next? Thank you. Divide by -3 on both sides.
X equals 3.
Doesn't equal.
Oh, X
Greater
is
than
greater than. X is less than.
Thank you. Why?
It's divided by
Yeah, so we have to do flippies. So instead of a greater than symbol, we have a less than symbol. And what's this? 3. Good. So if I wanted to graph that alone and give it its own graph, it would just be very simple. I would just make 3 on a number line. Would I fill in my circle? Nope. And now I have to show that x is less than 3. So
Go to the left.
what?
Go to the left.
Yep, to the left.
Yes.
Now let's look at the other inequality that wants to be friends. Okay, somebody tell me how to solve this. Just call it out. Good. I'm trying to go closer so you guys can see. Can everybody see on that side?
Sure.
Okay. What do I have?
2x minus 4
Good.
is less than or equal to 6.
Greater than or equal to 6.
Plus 1.
And then so you add 4 on both sides.
2x is less than or greater
Nope, we're
than
not doing flippies.
or equal to 10 by x equals 1.
Good. Oh, not equals.
Oh my God.
X is greater than or equal to 10 or 5.
To 5. Okay. Now let's graph this.
Excuse me?
Yeah?
Really quickly. So on the question you did, the one on the left.
Yeah.
So there's a minus 3x. So why did you minus the minus 3? Which
I didn't minus the -3. I divided by -3. X was multiplied times -3.
Oh.
So I divided the opposite of what was happening to x. Good question.
Okay, that makes sense.
Okay, so now when we do the graph over here, we can have our +5 here. We have to show that x, oh, I gotta circle it. Should it be filled in?
Yes.
Yes.
Absolutely.
Why?
Because it's equal to as well.
Yes, because the equal sign as part of the inequality means that 5 is included. On your homework, you might see a problem that says inclusive. That simply means we are including the value with either with a filled in circle or with an equal sign as part of the inequality. Okay, so it has to be greater than that, so we're gonna go to the right. Now, it says graph the solution. We have two totally separate inequalities that we graphed. How can we make them all lay the same playground? Yeah,
Okay, so first you make a graph with 0 in the middle.
okay.
No, not 0 in the middle.
I can, oh no, yeah, we don't want 0 in the middle. I've got good news for you. Just graph your numbers. How about we put 3 here
and then
and 5 here, because that makes sense. We wouldn't want to switch them because we do want them to be correct on how they would be on a number
And
line.
then after that, for 3, you just put a open circle
Yeah,
and going to the right, or no, going to the left.
yeah,
And then after that, you're gonna have a closed 5 or a closed circle going to
Yeah.
the right.
good. So they're on the same graph, they're kind of hanging out on the same playground, they're just not playing together, okay? But they're both at the same playground, they're just not playing together. Meaning there are 2 separate solution sets, okay? And that's okay, they're just hanging out on the same playground. And that's what that looks like, okay? So your answer to this problem is 2 parts. First it says to solve it, so we would say x is less than 3 or x is greater than or equal to 5. Since they don't meet, they don't overlap, they don't connect in any way, we would just have 2 separate inequality statements and we would just say this or that, and that is the answer. That's the answer to solving it, and this is the answer to graphing it. Yes.
So, I know we learned this last year, but I forgot. So what's the difference? Like, how do you get each, like, of the different circles in the middle? You know how they look different?
Yeah.
How do you know which one is which? So.
How do I know if it's filled in or empty?
Yeah.
Okay. Let's go over this real quick, guys, because I've had a couple of questions about this already.
Oh,
You got it, right? Did somebody just say oh?
that was
Oh,
me.
that was you?
Yeah, because I know how to.
Could you tell me, why would a circle be open?
It's open if it's grade if it's like basic, like less if it's
It doesn't have an
less
equal
than a
sign.
grade.
It's probably
If not
easier to
equal
explain why it would be closed, right?
Yeah.
Why would it be closed?
Because-
Or filled in?
Because it's equal to your grade.
Yes, because because it includes it. So I could do it like this. Less than sign or greater than sign would be an open circle. If you want to write that down, you can. Open circle. Less than or equal to, greater than or equal to would be a closed circle or filled in circle. Because the equal sign, that part, is what says that this, filling this in, it says include the number in the solution set. So this is saying that the value of x could be higher than 5, and it also could be 5. That's why we fill it in, because we want to show that 5 is included in it, okay? This one is not included, so we're saying any value that's less than 3 works, but not 3. Jack, wake up please. All right, let's move on. This was a review from yesterday, but let's move on to the.
So that was all we did yesterday?
That. Were you not here?
No, I was. I was. Remember, I wasn't feeling well, so like kind
Oh,
of.
so it kind of
Yeah, like.
breathes right over you? Yeah, okay. All right, I only have 2 problems to go. Oops, with you. But you know that one was gonna be a word problem. It's not gonna be that bad, don't worry. Okay. Now, we have a little situation where the inequality is kind of overlapping with another inequality. That's kind of weird, right?
Oh.
We've got like 2 inequality situations, but they overlap, they kind of share a middle. So how do we solve that?
In between, we just get both of them.
Yeah, we would have to solve both of them separately. We would have to kind of separate them. And since this belongs to this side, but it also belongs to this one,
What side does it belong to?
it belongs to both. So we're gonna write 2 inequalities, but both with the 7x plus 9. We will, Jack, can you just take it? I know. Okay, good. Okay, thanks, Bo. Okay, just gently, okay? You can just give him tappies on the shoulder, okay? Tappies. I have little kids, so everything ends like in a X or something. I don't know. Okay, shh, are you with me?
Yes.
Okay.
Indubitably.
Indubitably. Okay, so we're going to separate them into their own inequalities to solve them separately. Then we'll join them back together, because obviously they're joined together, right? If they're sharing something in the middle, they're nice and joined together. We're gonna separate them to solve, and then bring them back and see if they wanna play at the playground together, okay? So, first we take our red box here, and we have -12 is less than or equal to 7x plus 9. I don't love the way.
Why do both sides have the same?
Because they're sharing this.
At the end, when we like put it back together, or we like.
Yes, we will put it back
Would they merge
together.
into one, or would it be like I don't know?
It will merge into one, and I'll show you that, I promise. You are the kind of guy who watches the movie and wants to know the ending right away, right? Sometimes?
No, I'm just like really confused.
Okay, you're just really confused. Don't worry, I'm gonna walk you through every step, okay? I don't wanna spoil the ending for you yet. Let's just watch the movie together, okay? So we have this inequality first, and you know how the book does it sideways, and I don't like doing that. So I do -9 over here, -9 over here. Cancel out my 9s, and then I have a -12 and a -9. I get a -21. Is less than or equal to 7x. Oh, I just always want to do it on my own. Okay, -21 is less than or equal to 7x. I just need it bigger and more spacious.
How'd you get 21?
Because
Not
-12 plus -9. We have to remember our rules for.
Flip the 12.
Oh no, I didn't just like switch the digits. That's crazy. All right. So then we get x by itself, divide by 7, divide by 7, and we get what? Good. So we have -3 is less than or equal to x. What's the other way that I'm allowed to write that?
X is greater than or equal to.
Very good. I can write it both ways, right? I can do switchies and flippies. Switchies and flippies is okay. So sometimes you're just gonna wanna write them both ways because you never know which one is gonna be more helpful when you actually graph. In this case, if we're just graphing this inequality, I think it's actually easier to graph it using this where x is first, okay? So if we graph this and we have our -3 here, we have a filled in circle, right guys, because of the equal sign. And then we have x is greater than it, so it's gonna be everything to the right, towards positive infinity. Yeah.
When graphing it, can you just like technically say like the algebra mouth is like you take like turn it into an arrow and like the arrow is pointing to the way.
Arrows pointing to the
Yeah, so like for the 3, it's pointing this way, so
Yeah.
the arrow's going that way. Can we just like?
Oh, yes, unless it's written this way, which is also true, and then that can be confusing, because you might be like, well, if the arrow's pointing this way, then it's pointing to the left, but this is the same as that, right? And it's pointing to the right. Excuse me. That only works if your x value is on your left-hand side. So yes, but only when it's written like that. Okay, which is when you started learning about inequalities, that is how everything was, so there. So we solved it, we graphed it. Let's go to our other part where we still have the 7x plus 9. 7x plus 9 is less than 16. Walk me through this, guys, quick. Thank you.
And then 7x, and you have to divide both sides by 7.
Hold on, less than. What? 7, okay.
Divided by 7.
Divide by 7 on both sides. Do I have to do flippies?
No.
No, because I'm not dividing by negative. So I
X
have
is
x is less than 1. 7 divided by 7 is 1. So I have x is less than 1. I could also say 1 is greater than x if I want to. I'm not going to need to. But we can graph it on its own graph. I just put my 1 here. The book loves to put zeros here to show which side the 0 is on. I don't find that to be necessary. If you were to write this just for me, you don't have to include the zeros. On your homework and test, it will be written for you, and then you would just choose the right graph. Okay, so on this graph, we would say x has to be less than 1. Open circle, right? Open circle, because it doesn't include the 1.
Those are my best friends. Open circles.
Oh, okay, open circles are best friends. Okay, so it has to be, here, chatter. Okay. Go ahead. Okay. Back to me. No, not time to chat. No. Okay, good. All right, so we have x is less than 1, so we're going to show that it is less. And again, yes, as long as your x is on the left side, then your arrow will be pointing in the direction you want to go. But look what's happening! They're at the playground together and like, hey friend, how are you? And this one's like, hey friend, how are you? Do you want to play together?
Absolutely.
Yeah, let's go. Absolutely not.
I'm good, you know.
No.
I'm open for
Uh-oh, it's, we're going off topic, okay? Is it an emergency? Okay, can you wait till that's over then? Because we only use the bathroom if it's an emergency while I'm teaching, okay? Right, yes.
So,
I'm gonna get there, I'm not done, I promise.
I know, no.
Okay, you don't understand something about this?
Yes.
Okay.
So, from
Hey, shh.
from what I did, the x salary amount one or whatever. So why is it going towards the left? Wouldn't it be going towards the right, like usual?
Well, this one is going towards the right and this one's going towards the left, and what's happening is the solution set, they actually meet and they play together at the playground.
Oh,
So,
right, because it's one big.
it's one big happy
It's like
family.
that one example where they have the dot and the dot is aligned with it.
Yeah.
I forgot that
So
one.
we're gonna graph these on the same graph at the same playground and see that they're actually playing together. The graph is the same, it's just that instead of continuing all the way, it stops at the 1 because it sees its friend. And then 1, instead of continuing down, it stops at the -3.
So they kind of just like cancel each other.
Yes, so what this graph is saying is that the solution set means that x can be any value
In between.
in between, from -3, including -3, to 1, but not including it. So give me a couple of values that would work for this inequality.
136.
Negative.
What?
When are they those today's one?
No, yes,
0.
0, good, -1, yeah.
3.
Yeah, what about like -2.9?
Yes.
Yeah.
Anywhere between -3
Right.
and 1.
What about
Or-
0.9?
9.
Yeah.
Why are you going to
Okay, because I'm just showing it's not just whole numbers or integers. It's including fractions and decimals also, right? Okay, shh, I'm not done. So we're just finding the solution set that we could fill in for x to make this true. Now here's the other part. Graphing it is not the only part of the answer. You have to be able to write the solution set, okay? So, since we agree that x is greater or equal to -3, and it's also less than 1, we can show that x, since they're playing together at the playground, x is in between them. How do we write it? Just like this. X is in between the -3 and the +1, but let's look over here. We have our -3 here is less than or equal to x, just like what we solved. And over here, we have x is less than 1. Now, if you didn't have any of this, but they just gave you the graph, you still would be able to write this, because you know that x has to be in between, right? And then you can read it like this. -3 is less than the values for x, or equal to it, so less than or equal to x, and x has to be less than 1. So this is the graph, this is the answer to the inequality, yeah.
Will we do this with like graphs where like they go up and down?
Not now.
Yeah, nothing now, but
No, not-
later.
Oh yeah, we're gonna do parabolas.
Oh yeah.
Things are gonna get crazy. You just
no.
wait. Hey, I need you guys to try this one on your own. Don't be scared.
I'm scared.
Grace is not bad.
Freaking out is not going to help us, it's going to waste time. Thank you to the people who are already copying this down. Call me over if you need help. That was quick.
I think the help you need is mental.
Yes, that was a good question. Remember, what do we have to do to solve this? We separate them. How do we separate them if they're joined together here? This belongs to this side, and it belongs to this side. So it gets included in both inequalities.
What if there's two on the same one?
I need help.
Okay. Yeah, so you have like terms, your like terms are 2x and 4x. So you can go across. No, you wouldn't be adding them together. It would be
But that's.
okay, so I just said that we have to separate them now, right? Yeah, or a decimal. It's not a serious. You're not doing it right, you can separate them. Oh, this is good. The only thing is, this should be negative 2x because if you're subtracting. No, wait. Oh, okay, we went the other way. We have to subtract 4x. We're trying to. Yeah. Because if you do that, that's going to be. And then you have 0. And then that's just more confusing. All right, here's the deal, guys. I'm noticing that a lot of people need help with this. If you feel like you got this, then very quietly continue on your own, okay? But if you want help, please pay attention up here. There is no third option of chatting, okay? You're either doing it on your own quietly, or you're up here with me. 2x is less than 4x minus 5. And 4x minus 5 is less than 15. We separate them. This belongs to both. Yes?
What?
Yes. Now, in order to solve, we have like terms here, okay? We have like terms. Hello? I feel like a lot of people that I just noticed need a lot of help are not paying attention. Jack, pick one. You're either paying attention up here or you're doing it on your own. Are you okay?
Yeah, my finger just hurt a
Oh,
little bit.
okay, I'm sorry to hear that. All right, pick one. We're either Lil, what are we doing back there? Are we doing it on our own or are you paying attention up here? Okay, so did you write both of these? Do you have both of them down? Good. Okay. So I need your full attention up here. Jocelyn, do you need help?
No, I did it.
Oh, you did?
Yeah, we both did it.
Good job. Now, if you did it, check to make sure it's correct, okay? So we're gonna subtract 4x from both sides. Raise your hand if you tried to subtract 2x from both sides. Okay. What happened, it wasn't just you, right? Was there anybody else who tried to subtract 2x from both sides? I'm gonna show you what happens when you guys subtract 2x from both sides? Oops.
It's gonna be wrong.
It's not gonna be wrong. It's just not gonna be helpful, because I'll get 0. This doesn't cancel out, guys. I mean, it cancels out to 0. But then if it cancels out, you still need a value on this side of your inequality. So you have 0 is less than 2x minus 5. Isn't that just as complicated as you had it up here?
And then you just minus.
If you want to, you can add 5 to both sides now. And then you get 5 is less than 2x, then divide by 2, then divide by 2. You can do that,
It
but
works either way.
it does work like that, but it's adding an extra step. Canceling something out so that 0 is on, because I don't want you to solve it that way. Sorry. That was the, if you did it this way, it's not wrong, but it's more complicated. I'm showing you the simple way. Subtract 4x from both sides. So you don't end up with 0 on this side of the inequality. Negative 2x is less than,
No, flippies, right?
no flippies. I didn't divide. You only do flippies when you are dividing by a negative or multiplying by a negative. Now we have to do flippies, right? Because we're dividing by a negative, so we have x is greater than, oh no, 5 over 2. What is that? Give it to me in decimal. 2.5. 2.5. And then it's going to be positive. 2.5. Okay? No, positive. Negative divided by a negative is positive. Okay, so we have this. We have this. We can also write it the other way, right? 2.5 is what? Less than x. Both of these are correct. As long as you do switchies, you can do flippies. Okay?
We can do it first.
Either one. Okay, now let's come over here and solve this. Come on, this one's easy. Work it out quickly.
Okay, so you plus 5 on both sides.
Okay.
And then after that, you divide by 4x on both sides.
Okay.
And you get x equals 5.
Not x equals.
Or x is less than 5.
Good. Now, I want you guys to notice something. If I graph this, okay, I'm going to graph this one over here, okay? If I graph it, I have my 2.5, right? Let's read this one first, because it's easier to graph where x is. Open or closed? Open. It's greater than 2.5, so which way should I go?
Right.
Yep. Let's graph this one. Open or closed?
Open.
Good, which way?
Left. Boom. Do it.
Are these gonna meet at the playground and play together?
No.
Yes.
Yes, they are. Because the 2.5 is like, hey, anybody want to play with me this way? And the 5's going, I'm over here, let's meet on the slide. So they're gonna join together on a number line that has 2.5 and 5, both open circles, and they're gonna play together, okay? And now that they're playing together, we need to make sure that we write this solution in terms of the inequalities. X is in the middle, right? 2.5 is on the left, 5 is on the right. And how do we write it? 2.5 is less than x, and x is less than 5.
Boom. Do
Boom.
it.
Boom, chicka, boom.
Remember when that song was popular?
I'll give you guys a second to catch up, but I don't need talking. We are not done. We have a word problem next. It's about a puppy. If you really need to, but you're gonna miss the word problem.
I would eat that.
I'll be zoomy fast.
Zoomy, okay.
Well, like you're not very going to.
Bo, I don't need to. All right, can I move on? And we can talk about a puppy? a puppy named River?
Yes.
Yes.
Really?
Oh, Miss
Oh,
Sports
Spanish
Dog.
teacher.
Miss
Huh?
Sports Dog. Her name is Rio in Spanish.
River.
Oh
It's
my
a
gosh,
river.
that's perfect.
My friend
Okay.
name is River.
That's wonderful.
there a dog?
Oh my god, and
Enrique. That's funny because her dog's name is River, but in Spanish, and
It's
then this
Rio.
name. So we'll call it Rio. Okay.
No.
Enrique.
Video.
Okay. Enrique plans a diet for his dog. Uh-oh. His dog needs to be losing weight. Dog's getting too chubby. Rio is getting a little thick around the middle. Okay. So Enrique's like, you'll need to go on a diet. Okay. Getting too thick.
Rio.
Getting a muffin top. Okay. That doesn't really happen on a dog.
You got your phone.
Okay. May I continue?
Yes, ma'am.
Thank you. So he wants to put him on a diet. He's like, Rio, listen, I'm gonna feed you, buddy.
You're fat.
But you're too fat.
You gotta
You gotta slim down. It's bathing suit season coming up. You gotta slim down. Some dogs wear bathing suits.
Tuxedo.
Hit the gym.
Uh-oh. Uh-oh, I'm losing you. I do this so that I can keep your attention, but not so that we can trail off into other conversations, okay? So, also so that it's interesting for me too, because I would just be too bored if I was, we couldn't have fun. So Enrique says, okay, Rio, I'm still gonna feed you, but your diet means you can have somewhere between 510 calories and 540 calories per day. That's what excuse me, boys, I need your full attention. I'm still gonna feed you, but whatever I feed you needs to stay within 510 calories to 540 calories per day. First of all, that seems like a really small amount.
Yeah.
It must be like a chihuahua or something like that. We'll see, a chihuahua. Okay. So I hope he's not putting him on too strict of a diet, because that would not be nice. It's probably just a really tiny dog. So, do you agree that whatever Rio eats has to be in between 510 and 540? Are you feeling an inequality getting set up? If it has to be in between 510 and 540. It doesn't have to be a perfect exact number like 522. It can be a range of calories, right? So somewhere in between 510 and 540. So I'm just gonna write that over here. So the number of what he can eat, what Rio can eat, or the calories that Rio can eat. His calories has to be somewhere in between 510 and 540. Now, I'm just going to clarify the book just because I know what the book wants you to do, because I think it's a little bit confusing that they say between 510 and 540 calories. So it's kind of a question like, well, is 510 okay and is 540 okay? In this case, we're going to say yes. It's a little controversial, right? Because it's like, well, should it be 511 calories, right? It's a little tricky. But in this case, we're going to say yes. You can have anywhere from 510 calories all the way to 540. So we are going to include them, okay? So do you agree that the calories that Rio has to stay in between is 510 and 540? We set up our inequality already. We just don't have anything in here, but we have an inequality. Now let's see what he eats, what Rio eats. Rio, is it a girl or a boy? I don't even know.
Boy.
It's a boy.
It's a
Okay.
girl, it's a
Boy.
she.
Too bad, it's a boy.
Oh, she. It's a girl.
No,
Forget one.
So it's a girl. Rio eats 1.5 servings of dog food each day. How many treats can she have? She's like, Master Enrique, because you know how like your owners are masters. I'll go on this diet, but you still need to give me some treats. And he's like, well, I already feed you your dog food, so that's gonna take care of a lot of the calories.
Is it only
And she's like, but can I have any treats? He's like,
So hungry.
well, your treats are 15 calories each.
dang.
So I don't know if you can have any treats. Maybe. Let's see.
I give him 2.
How many calories a day is Rio eating just in food?
Too much. He's fat.
480.
Very good. Now, it's okay, you guys answered the question because I didn't give you all of the information. I was just curious to see if anybody paid attention to this. He eats 1.5 servings of his dog food. So if he eats 320 calories, then per serving, and he eats 1.5 of those, how would we figure that out? 320. No. 300. Okay, he eats this 1.5 times a day. Okay, times 1.5. So that would be his daily calories from his food. Okay, so his calories from his food are going to be 480. Or for her food is going to be 480. But she also wants to add some treats. But we don't know how many. We just know that they're 15 calories each. Let's use X to represent how many treats. How would I represent?
X. T.
I'll just use X, but
15.
15 what?
15x.
15X, because I have to represent how many calories each treat is. So do you agree that now I have 510 is less than or equal to 480 plus 15X is less than or equal to 540?
How did you get?
We did math.
Oh, I was.
I got the 480 because each serving of Rio's food is 320 calories, but it says in a day she eats 1.5 servings. So we had to do the math to find out the total number of calories she gets just in her food by doing 320 times 1.5, because that's how many times she eats 320 calories. Okay, that's where we get our 480. How do we get our 15x? Well, this is how many calories she eats in a day, but she also wants to add some treats. So if I said she wants to add 1 treat, how many calories is that?
15.
Good. If she wants to add 2 treats, how many calories is that? 30. 3 treats.
45.
Good. You guys are so on the right track, but the only problem is we still don't know how many she would have. So we just have to represent that as 15 times the number of treats. Okay? 15 calories times. What you guys were doing was 1 times 15, 2 times 15, 3 times 15. So all we know is it's going to be X times 15. A missing number times 15. Hold on a second. Are you guys with me now?
Yep.
Okay. Now here's what's cool about this problem as opposed to this one. Remember how this one we had to separate them? The reason we had to separate these is because you couldn't, there were no like terms. When you wanted, if I wanted to do +5 over here, I could do it here, but I couldn't add 5 over here, and because I didn't have another term like it. I got it. Hello, Mrs. Lake. Sure. You're welcome. Bye-bye. Natalie to the office during passing period. Okay, just stop at the front office. Okay, so on this one, we couldn't leave it as is. We had to separate them because they didn't really share like terms on the outside. But watch this. Now, we can actually, if we want to subtract 480 from here, we can do it on both sides because we have the same type of term. Before, we had an X term and a 15 term, we had to separate. Now, we don't need to write 2 separate inequalities. We can solve it by subtracting 480 from all sides.
No, there's 3 sides.
And now we're just keeping it balanced, okay? This cancels out, and we have 510 minus 480 is 30.
Are we allowed to separate them?
you wanted to, absolutely. Yeah, it'll take longer, but you'll get the same answer. Less than or equal to 15x, see how simple it got in the middle? Is less than or equal to 2060. Now what do we do?
Divide 30 and 50.
Subtract 15.
I can't, I would have to subtract 15x.
Oh,
and-
divide 30 and 60.
Divide by 15 on divide 15.
Yes, thank you, Jack. Now, because we're doing, like, we have like kind of like a three-sided figure here, we're gonna not just do it on both sides, we're gonna do it on all parts, okay? So we divide by 15 in the middle, and then yes, we do it on both sides of the inequality. Now, cancel, cancel. You guys really need to focus. Do you have all of this down? All of it?
Not all of it, I'm
Okay, but it needs to be continued while I'm doing it.
Okay.
Okay, 30 divided by 15 is 2, is less than or equal to x, is less than or equal to 4. So how many treats can Rio have?
4. 6.
He can have
He
3.
can have from 2
He can have 2 to 4.
Yes, he can have 2 treats, or she can have 2 treats, or 3 treats, or 4 treats. This is the answer.
I'll give her 9.
She could have anything from 2 to 4 treats. Now, if you can tell me, what if I told you that everything stayed the same, but instead of 15 calories per treat, it's 10 calories per treat? If you guys can do this in the next 2 minutes, and yes, well, it's okay, I still have 2 minutes of class. We're doing the same thing, but instead of 15 calories per treat, it's 10. Oh, I don't care if there's people at the door. My class isn't over for 2 minutes.
It's 3.
I can't see.
4.
Okay, you cannot shout out the answer, or I will not give you these candy. If you get it right, write it down.
I can't see.
No.
The answer.
If you want to go, you can go. If you want to try to solve it, solve it. Can you press end on that? Can you turn it off?